This is Algebra 2, Lesson 7-1, Graphs of Quadratics in Vertex form. First, I'd like to talk about the pattern with squares. So let's go ahead and assume that we have this function where we just square everything. It's x squared. So if I plug in, I want to start down here at 1. If I square 1, that means x is being plugged into this x here. 1 squared is 1, which means 1 squared is 1. I'll write that over here. When I plug in 2 into x, that means this x over here is now 2. 2 squared is 4, and I can keep writing out my squares. 3 squared is 9, 4 squared is 16, 5 squared is 25. What I care about most, and I guess I can go ahead and say that 0 times 0 is 0 squared is 0. What I care about most is looking at the pattern to get to the next square. I want to fill in the blanks here. To find the next square number, I do what by what number. So I'm just going to go ahead and say to get from 0 to 1, I add 1 plus 1. To get from 1 to 4, I add 3. To get from 4 to 9, I add 5. To get from 9 to 16, I add 7. And to get from 16 to 25, I add 9. You might notice the pattern with these blue numbers. The pattern is that they're all odd numbers. Not only are they odd numbers, they're consecutive odd numbers. 1 is the first odd number, 3 is the second odd number, 5 is the third odd number, so on and so forth. Which means if you want to find the next odd number, all you need, or the next square number, sorry, to find the next square number, you just add, so I'll go ahead and fill in here. What we need to do is to add by the next odd number. And this is a shortcut to graphing. So if I come over here, this, by the way, is called the parent function. I'm going to go ahead and label that as well. So this right here is called the parent function. The parent function just means every function that we're studying today is based off this one function. So let me start at 0, 0. 0, 0 is the origin. That is a point on the graph. Again, I'm just graphing x and y here. X and y is 0, 0. There's one of the points on my graph. So I have my first point, and this is what we're going to do. Every single time we're going to take a step just once to the right, a step once to the right, a step once to the right, which corresponds to stepping once in the x direction, once in the x direction, once in the x direction. So if I go one step right, I'm going to go one step up. So if I go one step to the right, I'm going to go one step up. And I get another point. I'm going to take another step to the right, but instead of going up 1, I'm going to go up 3. So now I'm going to go step 1 to the right, but now I'm going to go up 1, 2, 3 to get our new point up here at 2, 4. And then I'm going to take another step. I was at 2, and I'm going to go to 3. I'm going to go from 2 to 3. It's taking a step to the right, but I'm going to go up a distance of 5. So I'm going to go right 1 and then go up 1, 2, 3, 4, 5, and I have another point. And these do define a curve. It's called a parabola, and it generally comes up in this. Okay, I'm not the best artist. I can try to do a little bit better than that, though. It does generally come up in a curve. Let's change my color here. It comes up in a curve like so. Don't know why that happened. There we go. So why do we need to know that? Can't we just plug in, 3 squared, I know it jumps up to 9. The problem is this vertex doesn't always end up to be the origin. Sometimes this vertex, and by the way, I should label that since this is maybe some new terminology. This turnaround spot is called the vertex. It's where our function turns around. And to show how that turns around, I like to do the rest of this table over here. If I plug in -1 into x, -1 times -1 is +1, which means up here I have a +1, and similarly, -2 squared is a +4, +4, and then +9, +16, and you can see that the pattern is the same on the other side as well. So what we have essentially found is that through 0, we have this axis of symmetry, which means it's going to have the same thing. To get from 0 to 1, I'm doing +1. To get from 1 to 4, I'm doing +3. From 4 to 9, +5. And from 9 to 16, I'm doing +7. I don't want to keep doing the math all over again since I've already done it. So what I'm going to do is use geometry to just find the find some new points. So if I went right one, up one, I'm going to go left one, up one. I can say, okay, this point is reflected across this axis of symmetry that goes always through the vertex, which means just eyeballing gives me a point over here. And looking at this point, it goes 1, 2, therefore 1, 2, and we have a point right here. And then 1, 2, 3, count 1, 2, 3, using the axis of symmetry and a reflection, we get our other points over here. So using the axis of symmetry, we quickly find that we have this other parabola, the other left-hand side of the parabola that goes like that. Cool, so that's how you generally graph a quadratic. And it's using this pattern where it's always increasing by odd numbers. So it's always right 1, up 1, right 1, up 3, right 1, up 5, right 1, up 7. It's always right 1. This side is always right 1. I should probably write that out because that is important. Just let me rotate. This is going to be always go right 1, and then these are going to be how much this amount right here is how much we're going to be going up. All right, so how does that help us graph these functions? So let's actually talk about the topic today, which is vertex form. Vertex form, we're going to be learning 2, I think, different forms in this unit. This is the easiest by far. Generally, you're going to have some sort of notation. This might be an F, it might be a G, it might be an H, some letter of X, and this is what you're paying attention to. Do you have something with parentheses squared with maybe a plus sign on the inside? If you do, then it's most likely vertex form. Again, all the homework today is going to be vertex form, but later on, the hard part is determining, is this vertex form or is it some other form, like standard form? So if you have a function that looks kind of like this, that is vertex form because you have something inside the parentheses square. You can see there's a +2 inside, a -8 outside. That is a characteristic example of vertex form. And in today's lesson, we are going to ignore the A. So let me actually cross this out. So we're going to talk about that. What unit is this? This is unit 7. So this is going to be in lesson 7-2. We're going to be talking about A. And I'll move that off to the side because I don't want that interrupting us. What I do need to talk about is what's going on with this B and what's going on with this C. How do these numbers affect what happens with our parabola? By the way, the shape up here, I said it out loud, but the shape up here is a parabola. So everything that is a quadratic is a parabola. So up here, quadratic is synonymous. This word right here means it's something x to the power of 2, which is synonymous with saying that you have some sort of parabola. All right, so what do B and C do? What I'm going to do is I'm going to type in this function. I'm going to ignore the A, so it's just going to be blank, and we'll see what happens when I do a slider for B and C. Let me pull up my Desmos calculator. So there it is. You can see in the top left I have the function. I forgot the A on purpose, and I have B and C. So I'm going to drag the slider for B, and I want you to pay attention to what happens to my function. So I'm going to drag the slider for B to the right. Interesting. I'm going to drag it to the left. It looks like it's just moving it kind of the opposite direction that I'm moving the slider. It's moving it left and right. If I move the slider to be a bigger number to the right, the parabola moves to the left. If I move it to be a negative number, it moves it to the right. It's kind of the opposite of what's happening. And what about C? When I move C, let's move it to the right. Seems to move the parabola up. And when I move the slider to the left to make it a negative number, it moves the parabola down. In fact, not only does it move it down, I would say that the y-coordinate of the vertex is that number. So if I leave it at -3, you can see that the y-coordinate of the turnaround spot, the vertex, is -3, and I can change it's going to be opposite of this, but I can say that the x-coordinate is going to be opposite of 2, which is -2. It seems that the B on the inside affects the x-coordinate, and the C on the outside affects the y-coordinate. The B is opposite, whereas the C is not opposite. If I go up with C, it goes up. If I go down with C, it goes down. All right, so let's go ahead and take that back to our notes. We can say that B is affecting how much left and right I go. So I'm going to say the words, this affects the left and right, whereas C if X, if it goes up and down. And I will make a note here. So note, this one is normal. There's no reversed behavior, whereas this one is opposite. Okay, so, and I guess the vertex will have the, if I'm being super formal, I'll say that the vertex is at, you do the x comma y, the y coordinate is always c, and the x coordinate, I want to say it's b, but you have to do the opposite, so I'll put a negative b, and that will always be the x and y coordinate of the vertex. So I only have this equation up here to show what an example would look like, but I want to actually jump into some examples down here. So these are very similar to what you would have on homework. So for example 1, there's our function. Notice it looks like vertex form. We have parentheses with numbers inside and outside with a power of 2. Power of 2 means it is going to be some sort of parabola. So the very first thing to do is I need to find the vertex. The vertex, I'm going to not go left. Again, inside number is always moving it left or right. Normally I would think, oh, this goes right because it's positive, but inside the parentheses is always opposite. So instead of saying right 1, I'm going to say that this plus 1 means go left 1. And this plus 3 is the up or down, and it's normally up 3. So this one is just up 3. So from the origin, I'm going to go left 1. So here's the origin. I'm going to go left 1. I'm going to go up 1, 2, 3. I get this point right here. And say, okay, that is the vertex. And then from the vertex, I'm using that pattern of squares up here, where from the vertex, I went right 1, up 1, right 1, up 3, right 1, up 5. Maybe I should draw that up on here. Kind of this stair pattern, right? This is the stair pattern that you're going to be using over and over again. It always goes right 1, right 1, right 1, but it goes up 1, up 3, up 5. It goes up by consecutive odd numbers. And that's exactly what we're going to do down here. We're going to go right 1, up 1, right 1, up 3, and by the time we need to go up 5, we're off the graph. And then I'm using this axis of symmetry, right? We have this axis of symmetry through the vertex, and I can reflect over that line and say there's a point over here and a point over here, and I'm done. There's my graph. So I have my parabola that comes up with arrows, my parabola that comes down through the vertex. One thing that I should note as well, when I go through the vertex, this vertex should be nice and rounded. Sometimes we talk about things where they reflect and bounce off, and it's kind of like this V shape. This should be more of a U shape. All right, we're done with example 1. Let's go ahead and do example 2. So first, I want to analyze what's going on with this. It is in vertex form, so I am allowed to use those tricks that I looked at earlier. When I have a -4, again, the inside will affect if I'm going left or right. So normally I would think, oh, this is probably left 4, but again, it's inside the parentheses, so it's going to be opposite. It's not left 4, it's right 4. So this -4 actually means go right 4. And this -2 controls what's going up or down, so this one will make it go down 2. So the vertex used to be at the origin for the parent function for just x squared, but because we have changed it, we are going to go right 4 down 2. I don't know what happened to my 2. And I'm going to say, okay, I was at the origin. I'm going to go right 4, 1, 2, 3, 4. Then I'm going to go down 2. So down 2 will go 1, 2. And I have the vertex. Again, once you have the vertex, then you're using that pattern. I'm going to go right 1, up 1, right 1, up 1, 2, 3. And then I'm using the axis of symmetry to reflect over and reflect over. Ooh, look, and I can even go even more. So normally I would go left 1, up 1, left 1, up 3, left 1, up 5. So I'm at 2. So plus 5 would go up to 7. And I have another point. And then I can go ahead and make my line that goes through these points, this parabola shape. Comes up and out. Good enough. And there's my parabola. Cool. So again, there are kind of two things to take away from this lesson. The first thing is the pattern of what to do when you have your vertex. When you have your vertex, use the square pattern of the always go right 1, then go up 1, 3, 5, 7 with odd numbers. And secondly, use the vertex form. The B and the C here will tell you how much to go left and right, how much to go up and down. Remember that this one is opposite. All right, so because you're still watching, I will give you some freebies. Let's go ahead and do number 1 together, and I'll give you maybe another one as well. All right, in number one, I'm going to first analyze what this function is saying. So when I have plus 4 here, plus 4 is the same thing as saying, okay, the inside number affects left or right. Normally, I'm thinking plus means go to the right, but it's opposite because inside, so this is going to say left. So I'm going to go left 4, and then plus 2, this is going to be the up or down number. This is going to be up 2. So let's go left 4, up 2. Left 4, the origin is right here, so I'm going to go 1, 2, 3, 4, and then up 2, 1, 2, and there's our vertex. Our vertex is at -4, 2. And then I'm using that pattern of go right 1, up 1, right 1, up 1, 2, 3, and that's as far as I can do. Then axis of symmetry, reflect over, and I have my graph. Done. All right. So let's do another one. I'm going to skip those. Which one looks fun? Let's just do number 11. Sure, why not? Ooh, it's tricky, right? Because it does decimals, maybe. I don't know. Maybe that'll trick someone. So first, I'm going to analyze what goes on with this function. So I'm noticing I have a +1 right here. Why is this? Whoa. There we go. So I have a +1. Normally, when I'm inside the parentheses, I'm left or right. I would think, oh, positive means right, but it's opposite, so that actually means left. So I'm going to go left 1, and when I'm on the outside, it's going to be affecting if it goes up or down, so this is going to be down 1. So left 1, down 1, be careful. Left 1, down 1, and there's my vertex. And then from the vertex, I'm always going to go right 1, up 1, then right 1, up 1, 2, 3, and I've run out of space, so I'm going to use the axis of symmetry, reflect it over, and I have some points, and then I do my best attempt to have a curved line that goes through those points. Ooh, not the best. Close enough. This should be a nice gentle curve down there. It's a little bit too sharp. All right, so that concludes lesson 7-1 for Algebra 1. Thanks for watching.